Welcome to the Copperfield Electric Podcast.
Thanks for having me. It's great to be here.
Yeah, glad you could make it. So imagine you come home from work, right? You plug in your brand new electric vehicle. You crank up the AC because it's absolutely sweltering out.
Oh, yeah, typical Southern California summer.
Exactly. And then you start the dryer, and suddenly, boom, your entire house goes dark.
Yeah, that is a very common nightmare these days.
Right. So today we're taking a deep dive into exactly why that happens. Why that dusty gray metal box in your garage, the one you never look at, why it might be completely unprepared for modern life.
It's honestly fascinating. I mean, the demands we put on our homes have just skyrocketed, but the hardware managing it all, it's basically from the mid-20th century.
Totally.
No.
So we're unpacking the future of home energy management today, and we've got two really illuminating sources for this deep dive.
Yeah, some really solid info on the table.
Right. So we have this article from May 1st, 2026 by Renee Hernandez. It's called What is a Smart Electrical Panel? And we're pairing that with actual service data from Copperfield Electric.
Who are, a very trusted local provider down in Southern California.
Right. We want to see how this futuristic tech actually hits the ground in the real world. So if you're listening and you've recently looked at that breaker box and wondered, is this thing ready for solar or an EV? This deep dive is for you.
Yeah, we're going to give you exactly what you need to know before you make any major upgrades.
So let's start with the baseline. I want you, the listener, to picture that standard breaker box.
The gray one behind the garage door, right?
Exactly. The one you only look at when half your kitchen loses power and you have to go flip one of those little black plastic switches.
Yeah, and according to the Hernandez text, those standard panels, they basically offer zero real-time monitoring.
Nothing. No Wi-Fi connectivity, no energy management. They just sit there.
Right, they're totally passive.
I actually like to think of a standard breaker box as a simple mechanical toll booth.
Oh, a toll booth. I like that.
Yeah, it just lets the electricity flow through the gate until there's this massive traffic jam of electrons, like a surge, and then it just violently drops the gate.
It just trips the breaker. Boom. On or off.
Exactly. Completely binary.
Well, the toll booth is a great analogy for the old standard. But a smart panel, that requires a totally different, conceptual framework.
Okay, so what's the upgrade look like?
You should really think of it more like a high-tech air traffic controller.
An air traffic controller. Okay, unpack that for me.
Well, an air traffic controller doesn't just wait for two planes to collide on the runway and then shut down the whole airport, right?
Right, that would be a disaster.
Exactly. They put planes into holding patterns. They sequence the arrivals and departures based on, priority and available space.
Oh, I see. So it's actively managing the flow.
Yes. A smart panel manages the flow of electricity proactively. It prevents the overload from even happening in the first place.
That's a huge leap in capability.
It really is. And Hernandez points out that this is all driven by digital networking. Instead of those simple mechanical switches, these smart panels use real-time energy monitoring.
Real-time monitoring, meaning I can actually see the sort of invisible heartbeat of my house.
Exactly. Every single circuit.
But, okay, let's play devil's advocate for a second here.
Sure. Go for it.
Why do I actually need to see that? I mean, if my refrigerator is running, it's running. I just get the utility bill at the end of the month, right?
Well, yeah, but getting the bill at the end of the month is, it's like driving a car by only looking in the rearview mirror.
Oh, man. Yeah, that's true.
Right. You only see the damage after it's already done.
Yeah.
Real-time tracking lets you see instantly, like second by second, which specific devices are pulling the most power.
So I could see if something is, malfunctioning?
Exactly. You might discover that, that 10-year-old chest freezer out in your garage, it's silently pulling 3 times the electricity it should be.
Just burning through cash.
Burning through hundreds of dollars a year. And because these new panels are connected via Wi-Fi, you aren't, standing out in the hot garage with a notepad trying to figure it out.
You just have an app on your phone.
Right. You have remote access to the entire system from literally anywhere.
Wait, really? So if I'm at the airport and I suddenly get that cold sweat realization oh no, I think I left the oven on.
Yep, the classic panic moment.
This panel actually gives me the ability to fix it right then and there. I don't have to call a neighbor to go check.
Nope. You just pull out your phone, open the app, and you can kill the power to the kitchen circuit right from Terminal B.
That is, just the psychological benefit of that is massive.
Oh, absolutely. Peace of mind is huge.
Yeah.
But the system also operates totally autonomously through instant alerts.
Okay, so what if I'm not checking the app?
Right. Well, let's say a circuit breaker trips or there's a sudden weird spike in energy usage. The panel actually pushes a notification to your phone immediately.
Oh, wow.
Yeah. So you find out your deep freezer tripped the literal second it happens.
Which saves all the food inside from totally spoiling.
Exactly. It pays for itself right there and saves groceries.
That proactive approach, that has to tie into physical safety too, right? Because the old toll booth model, it waits for the wires to get dangerously hot before it snaps shut.
Yeah, the safety upgrade is, it's arguably the most critical feature of the whole thing.
How so?
Well, standard breakers rely on a physical piece of metal. It literally has to heat up and physically bend to break the circuit.
That sounds kind of primitive.
It is.
Yeah.
And sometimes they fail or they just don't react fast enough. And that is what leads to electrical fires.
Terrifying.
Right. But because the smart panel is digitally monitoring the electrical load in real time, it identifies those abnormal patterns, like the precursors to a thermal overload.
Ah, so it sees the problem before it's a real problem.
Yes. It shuts down the circuit before it ever reaches that dangerous thermal threshold.
It's literally stopping the fire before the spark even happens.
Ex-
Okay, so that's safety. But the Hernandez article mentions a fifth feature, and this one hits the wallet directly.
Yes. Long-term savings.
Right, because if I have all this granular data about my energy usage, I assume I can start, playing the system a little bit.
Oh, you absolutely can. You can practice what's called true load shifting.
Load shifting. What does that mean for the average listener?
Well, utility companies often charge you different rates depending on the time of day, right?
Right, like those peak evening hours when everyone is cooking dinner and the electricity is super expensive.
Exactly. And then it's way cheaper in the middle of the night. So the smart panel does the heavy lifting of optimizing all that for you.
Wait, it does it automatically?
Yeah. You can program it to run your heavy energy tasks, like, say, your pool pump or charging your electric vehicle, specifically during those off-peak hours when the electricity is the cheapest.
Wow, so it literally automates your savings.
It does. It's incredibly smart.
Okay, so having this digital air traffic controller for the home, it sounds undeniably better. But it brings up a really important question for anyone listening.
Which is?
Why is the traffic suddenly getting so heavy? I mean, we didn't need these sophisticated systems 10 or 15 years ago. The old toll booth worked fine for my parents' house.
That is a great point. And it leads us directly into the heavy lifters.
The specific devices forcing this massive infrastructure upgrade.
Right. The landscape of home appliances has just fundamentally shifted. We are rapidly moving away from fossil fuels for our heating and our transportation.
And we're placing all of that massive demand directly onto the residential electrical grid.
Exactly. And the most significant catalyst for this entire change is probably sitting right in your driveway.
The electric vehicle?
Yep. The EVs.
Now, the text specifically highlights the challenge of managing multiple EVs, but I want to push back here a little bit.
Okay, let's hear it.
I'm asking this on behalf of a homeowner who might just be looking at buying their very first electric car. Can I just plug my new EV into that standard wall outlet in my garage, or just hire a guy to wire in a regular charger? Like, why does the entire central nervous system of my house need this massive, expensive overhaul just because I bought a car?
It's a completely logical question. I hear it all the time.
Yeah.
But it really just comes down to the stark reality of electrical math.
Electrical math. Okay, lay it on me.
So a standard 120-volt wall outlet,
Yeah.
normal kind you plug a lamp into, charges a vehicle incredibly slowly.
Like, how slow are we talking?
You're getting maybe 3 or 4 miles of driving range per hour of charging.
Oh, wow. Yeah, that's not going to work for a daily commute.
Not at all.
Right.
For a practical overnight charge that actually fills the battery so you can get to work,
Yeah.
you need a dedicated high-power level 2 EV charger.
And that runs on a 240-volt circuit, right? Like an oven.
Exactly. And that charger alone pulls a massive amount of amperage.
Right.
Now, compound that. Imagine a modern 2-car household. You and your spouse both plug in 2 electric vehicles after work. Then the summer heat kicks your HVAC system on. Then someone starts the electric dryer.
Oh, I see where this is going.
Yeah. A standard 200-amp toll booth panel simply cannot handle that level of simultaneous demand. It will overload, and those breakers will trip.
And this is exactly where that holding pattern concept comes back into play, isn't it? The air traffic controller.
Yes, precisely. The smart panel doesn't just let the breakers trip. It actively manages the bottleneck.
How does it do that without me noticing?
It digitally communicates with the circuits. So if you're nearing your home's maximum electrical capacity, The smart panel can actually temporarily throttle the power going to the EVs.
Wait, it can slow down the charging on its own?
Yeah, it might drop the car charges from pulling, say, 40 amps down to just 10 amps, just until the dryer finishes its cycle.
That's brilliant.
And then once the dryer stops and the quote-unquote runway is clear, the panel automatically ramps the EV charging back up to full speed.
So you never notice a drop in performance and your house never goes dark.
Exactly.
Yeah.
And furthermore, the Hernandez text notes that these smart panels fully support modern connectors, which ensures cross-brand compatibility.
Okay, let's clarify those connectors real quick because the article mentions NACS and J1772, which honestly sounds like total alphabet soup to me.
Yeah, it gets pretty technical.
So J1772, that's been the standard plug for most electric vehicles for years now. But NACS is the North American charging standard, which is essentially the Tesla-style plug that most major automakers are currently adopting, right?
That's right. Everyone is moving toward NACS.
So regardless of what logo is on the hood of your car or what plug it physically uses, the smart panel manages that electrical load behind the scene.
Exactly. The panel only cares about amperage, not automotive brands.
Makes sense.
But, EVs are really just one piece of this puzzle. The integration of solar power and home battery backups is where this technology becomes truly transformative.
Oh, especially in an emergency.
Absolutely.
This is actually a major pain point for a lot of people. You spend tens of thousands of dollars putting this miniature power plant on your roof with solar panels.
Yep.
Then a storm hits, the local grid goes down, and your house still goes totally dark. I mean, it is incredibly frustrating to have solar panels that you literally cannot use during a blackout.
Oh, it makes people furious. But it feels counterintuitive until you understand why. Traditional solar setups are specifically designed to shut down during a grid outage for a very critical safety reason.
Safety for who?
For the utility workers.
Yeah.
Think about it. If the grid is down, linemen are out there fixing the power lines.
Oh, right.
If your solar panels are still pumping electricity back into those lines while they're working, it could be lethal.
Oh, wow. I never even thought of that. So standard systems just automatically kill the power completely.
Exactly.
So how does a smart panel solve that problem without, electrocuting the repair crew?
It performs this amazing process called islanding.
Islanding. Okay, explain that.
When the smart panel detects that the street grid is dropped, it physically and digitally severs your home's connection to those outside utility lines.
It cuts you off from the neighborhood.
Yes, your house becomes its own isolated island. And once that connection is safely severed, the smart panel awakens your solar inverter and your battery backups.
It essentially creates a private microgrid just for your property.
It does. And more importantly, it manages that limited stored power for you.
Because you can't run everything off a battery.
Exactly.
Okay.
If you're running off a battery, you really do not want to dump all your precious reserves into running, like the hot tub or the guest room air conditioning.
Right, you need the essentials.
So through the app, you pre-program your critical circuits. The smart panel automatically sheds all the heavy, unnecessary loads.
And it directs the solar and battery power exclusively to the important stuff.
Yeah, like keeping the refrigerator cold, keeping the internet router on, and maybe supplying a slow trickle charge to your vehicle.
That is the key to actual energy independence.
It really is. It's life-changing during a multi-day outage.
Well, energy independence sounds like the ultimate goal, right? Being totally immune to rolling blackouts is a dream.
Oh, for sure.
But look, we have to do a reality check here. This kind of highly automated, futuristic tech, it comes with a catch.
There's always a catch.
Always. We need to look at the practical drawbacks of ripping out your home's electrical heart and replacing it. So let's talk about the price tag.
Yeah, it is a significant infrastructure project. The financials require careful consideration.
The Hernandez article provides a very clear cost range. We are looking at anywhere from $1,500 to $4,000 for a smart electrical panel.
And that fluctuates depending on the features you want, the physical size, the overall amperage of the panel, all of that.
Right. Now, if I'm a homeowner and my standard gray toll booth panel isn't technically broken, it's just old,
Yeah.
I'm looking at a $4,000 bill.
Yeah, it's a tough pill to swallow.
And the text also points out there is a steep learning curve for these Wi-Fi apps and all these energy management tools. So honestly, is the juice really worth the squeeze here? If I have to drop that much cash and learn a complicated new interface just to turn my lights on.
The upfront friction is very real. I mean, up to $4,000 is a substantial investment. And adjusting to software-managed electricity is a total paradigm shift for most people.
Yeah, my parents would definitely struggle with an app for their breaker box.
Right. However, You really have to weigh those initial cons against the whole life cycle of the home and the inevitable trajectory of our energy usage.
Okay, give me the big picture.
The long-term cost savings from optimizing those off-peak energy rates, that will chip away at that initial investment year over year.
So the ROI comes from paying the absolute minimum per kilowatt hour.
Partially, yes,
Mm-hmm.
but beyond the monthly utility bill, you are buying a profound layer of protection against electrical fires.
Right, that proactive thermal monitoring we talked about.
Exactly. Standard panels simply cannot offer that with the same proactive speed. But perhaps the biggest return on investment is just future-proofing your house.
What do you mean by that?
Well, if you plan to add a heat pump, or upgrade to an induction stove, or maybe buy a second EV in the next decade, your current panel will likely bottleneck those upgrades anyway.
Oh, so I'd hit a wall where I literally cannot add another breaker to the old box.
Precisely. You are spending the capital now to ensure your home can handle all future energy demands seamlessly without needing another massive overhaul in 5 years.
Okay, so the ROI is pretty solid, both in financial savings and in avoiding huge future headaches.
Definitely.
But the text includes a massive flashing neon warning sign regarding how this panel actually gets onto your wall.
Oh, yes. This is crucial.
It says this is absolutely, under no circumstances, a DIY project.
Never.
Now, I want to push on this because I know there are listeners out there who are incredibly handy.
I get it.
I mean, I've watched YouTube tutorials, I've swapped out light switches, I've wired in ceiling fans. What makes a main panel upgrade so uniquely dangerous that I shouldn't even attempt it?
Changing a light fixture and changing a main electrical panel exist in entirely different universes of risk. Okay, explain the difference.
When you change a ceiling fan, you flip a single breaker, which cuts the power to that specific wire. It's safe.
Right. No power, no shock.
But when you open the main electrical panel to replace the whole box, you are dealing with the raw, unfused utility feed coming straight from the street grid.
Wait, so there is no switch to turn off the street?
Exactly. Only the utility company can disconnect that feed. Improper installation at this level creates catastrophic hazards.
Like getting electrocuted.
Worse, we aren't just talking about a mild shock. We're talking about lethal voltage and arc flashes.
What's an arc flash?
An arc flash is a literal explosion of plasma and heat caused by a short circuit in high voltage equipment. It is deadly.
Oh my God. Okay, yeah, not a DIY project.
And beyond the physical danger, there is the legal reality of code compliance. Electrical codes strictly dictate how these systems must be grounded and bonded. A permitted, legally inspected installation is required by law in almost every jurisdiction. And I imagine the manufacturers aren't going to honor a warranty if they find out I wired it myself with a pair of pliers and some electrical tape, right?
Oh, you will immediately void the warranties on a very, very expensive piece of hardware.
Makes sense.
Furthermore, getting the smart panel to communicate flawlessly with your home Wi-Fi network, your proprietary solar arrays, and your digital EV chargers, that requires a deep understanding of both electrical engineering and digital networking.
So if I mess up the Wi-Fi setup,
A single misconfiguration can completely prevent the islanding feature from working during an outage.
leaving me in the dark anyway.
Exactly.
So if professional installation is an absolute mandate, if opening that gray box yourself is both legally dubious and physically dangerous, the next logical step for a listener is figuring out who to actually call.
Right, you need a highly qualified pro.
You need someone who understands the high voltage and the digital networking. So let's look at the service information from Copperfield Electric.
Yeah, they serve as a really strong analytical case study for the kind of local solution required for this complex transition.
What stands out to you in their data?
Well, reviewing their credentials gives us a very clear picture of the baseline expertise required. They operate in Southern California, and they are fully licensed, bonded, insured, and their entire team is background checked.
Which is the minimum threshold for letting someone touch your home's main utility feed.
Yeah, 100%.
I see their public license number is 1094740, which builds immediate trust because, it's verifiable. You can look it up.
Always look up the license.
But looking at their service data, what really stands out to me is their operational philosophy. They practice something they call honest diagnosing.
That's a huge green flag.
From a mechanical standpoint, this tells me that a lot of homeowners are probably being told by other guys that they need a massive $4,000 panel replacement when they might just have, a minor wiring issue.
Oh, it happens all the time in this industry. Copperfield focuses on finding the actual root cause rather than just upselling a total system overhaul.
Which saves the homeowner a ton of money.
Exactly. That approach is crucial when dealing with complex smart systems. Sometimes the issue really is just a faulty breaker, not a failing panel.
But when an upgrade is genuinely required, their specific service offerings align perfectly with those heavy lifters we discussed earlier, right?
They do. They handle panel upgrades specifically engineered for EV charging. They also manage new construction wiring, with a notable focus on accessory dwelling units.
Oh, ADUs. Let's touch on ADUs because they are just exploding in popularity right now.
They are everywhere in California.
Right. An ADU is basically a secondary housing unit on a single-family residential lot. Think of like a backyard cottage or a converted garage with its own kitchen and bathroom.
And the electrical implications of building an ADU are massive.
Because you're adding so much stuff.
Exactly. You are taking a property designed to support one family's energy needs and effectively doubling the demand. You're adding a second HVAC unit, a second water heater, a second stove. This requires incredibly precise load calculations.
To ensure the main house and the ADU can operate simultaneously without, dragging down the local neighborhood transformer.
Yes, this is exactly the kind of complex load balancing a smart panel and a professional electrician are required to manage.
It's the ultimate traffic jam for our air traffic controller.
Exactly right.
I also see in their service data that they do extensive LED lighting retrofits for both residential and commercial properties.
Which is a brilliant first step.
Yeah, I mean, while LED lights aren't as flashy as solar panels or electric cars, retrofitting an entire property to LED slashes the baseline power draw significantly, right?
Oh, it makes a huge difference. It frees up capacity on the main panel, so you actually have more headroom for those heavy lifters like the EV charger.
So it's basically the most cost-effective way to reduce your home's energy footprint before you even install a smart panel. So if you are listening and realizing your home is struggling to keep up with your energy needs, or maybe you are planning to add an EV or an ADU, you can see why this need for professional upgrades is happening all across Copperfield Electric's footprint.
And they cover a really massive region in Orange County in Southern California.
Right. To summarize their reach, they're handling these installations from coastal communities like Newport Beach and Laguna Beach.
All the way inland through Irvine, Anaheim, Santa Ana, Costa Mesa.
And Mission Viejo, Tustin, Huntington Beach, Orange, and Fullerton. They are deeply embedded in the realities of the local grid down there.
And their operational model reflects the totally unpredictable nature of that grid. We noted earlier how a smart panel isolates your home during a storm or an outage.
Right, the islanding feature.
But what if the hardware itself sustains damage? A blown main breaker doesn't wait for a convenient time.
Oh, never. The power never fails at noon on a Tuesday. It fails at 2 in the morning on a holiday weekend.
Without fail. Which is exactly why Copperfield maintains 24/7 emergency service and after-hours availability.
That's huge.
It is. A massive electrical failure is a critical safety hazard and a massive property risk. You cannot wait 3 days for a business to open while your frozen food spoils. Or, worse, your medical equipment loses power.
Right. They provide a rapid response to secure the system immediately.
Exactly.
Well, let's synthesize everything we've unpacked today.
It's been a lot of ground to cover.
It really has. But the core message is clear. The days of the simple mechanical toll booth breaker box are ending. Our homes are evolving into these complex energy hubs.
They really are.
Upgrading to a smart panel, that digital air traffic controller, it is no longer just a luxury for tech enthusiasts, is it?
Not at all. It is rapidly becoming a fundamental requirement for homes running electric vehicles, integrating solar power, and managing battery backups.
Right. It provides real-time monitoring, it actively prevents electrical fires, and it automatically shifts your energy usage to save you money in the long run.
But the critical takeaway from all our sources today is that the bridge between the old analog grid and this new digital ecosystem, it is verified professional expertise.
You simply cannot DIY the central nervous system of your home.
Please don't try.
The transition requires professionals who understand both the lethal nature of high voltage and the incredible nuances of digital load balancing.
Absolutely.
So if you are in Southern California and you are ready to modernize your home, or if you just need an honest diagnosis of your current setup, you can reach out to Copperfield Electric directly.
Highly recommend giving them a call.
Their phone number is 626-622-9694. You can also visit their head office, located at 1581 Copperfield Dr. Tustin, CA, 92780.
The technology to make our homes completely energy independent is finally here, and local professionals are deploying it as we speak.
It's an exciting time.
It really is. But as we wrap up this deep dive, it leaves us with a pretty compelling question to consider.
Oh, what's that?
Well, if smart panels are constantly monitoring exactly when and how we use power, I mean, tracking every appliance, every light bulb, and every habit in real time, second by second,
Yeah.
how might this incredibly granular data change our relationship with our own homes? Well, our houses eventually know our daily routines better than we do.